Okay, so we're up to the 2018 free response questions for AP Statistics, and we're going to look at number one first. So number one is a regression problem, and a problem that we generally do well on. We just probably need some reminders about some of the small things about this that will lose us some points. So the first question is about the manager at the grocery store who took a sample of 11 customers and tried to see when there are more people online, does it take longer for them to get through checkout, and trying to see if there's a nice linear relationship between that. And as you can see from the graph, there kind of is. We could see that as the number of customers goes up, the amount of time they wait in line goes up. Okay, great. So a couple things. We have this computer output here, and I just want to go over again how we write this as a regression equation. Now, it doesn't ask us to do this, but we might have to. So we're predicting time by the number of customers, right? So we have predicted time equals, well, the slope is the coefficient next to the x variable. So we have 174.4 times number of customers in line plus 72.95, right? The constant is your y-intercept, which we're going to actually need in a second. So part A says, identify and interpret the context, in context, the estimate of the intercept for the slope for the least square regression line. So the slope, sorry, I'm all over the place. The y-intercept is 72.95. So the intercept is 72.95, which tells us as the number of customers in line is 0, we predict there to be a wait time of 72.95 seconds. Okay? Does that make sense? Not really, right? If there's no one online, how could we wait 73 seconds? So part B, identify and interpret in context the coefficient of determination r squared. Now, it's very nice that they told you what the coefficient of the determination was, that it is r squared. They could give it without that. So r squared right here, right, we got 0.7333, which tells us that 73.33% of the variation in time can be accounted for by the linear model relating time to the number of customers in line, right? That's that our y, x, right? You're basically saying that 73% of the reason that time goes up is because of the number of customers. That means there are other aspects as well. Maybe the register person is really slow. I know that happens to me sometimes at the grocery store. Maybe there's an object that needs to get checked the price on. It could be a bunch of different things. So, part C says, one of the data points was determined to be an outlier. Circle that point on the scatter plot and explain why the point is considered an outlier. So hopefully we all go up and we all circle this point right here. Right? And now the explanation is where it gets a little tricky. Why is that an outlier? And I wrote, this point is considered an outlier since the actual y value of time is very different from the predicted y value for when there are 3 customers in line. All right, we'll do number 2 next.